This is the semester 1 review, and we'll do these one at a time here. Our first problem is a order of operations problem, so we need to follow our order of operations, which is Pemdas. So 8 minus 6 is 2, so we've got 8 minus 16 divided by 2 times 2 squared plus 6. So now we're still following our order of operations. Our next one is exponents. 8 minus 16 divided by 2 times 4 plus 6. And now we need to divide next. Even though multiplication comes before division in Pemdas, they're the same operation, so we work from left to right. So this is 8 minus 8 times 4 plus 6. Then we're going to multiply. So 8 minus 32 plus 6. 8 minus 32 is negative 24 plus 6 is negative 18. Our next problem, same thing, simplifying the expression. We need to work inside our parentheses first, so this is 4 plus 36 divided by 2 squared times 3 plus 7. And our next step would be to do our exponents. 4 plus 36 divided by 4 times 3 plus 7. And now we're going to work from left to right. 36 divided by 4 is 9, plus 9 times 3 plus 7. We're going to multiply. 4 plus 27 plus 7. Well, 4 and 27 makes 31, plus 7 makes 38. Our next problem, write an expression for the perimeter. So perimeter means all the way around the outside. So this side would be 2x and this side would be y. So we're going to add them up. 2x and 2x makes 4x, and y makes 2y. Same thing for our next problem, only now we have got an extra variable. So our x's and our x's, that makes 3x. Our y and our y's makes 4y. And our z, 4z minus z, makes 3z. So our terms are here. Okay, and this top is just telling us what number in the sequence we are. First term, second term, third term, and so on. So let's see, to go from 2 to 5 we need to add 3, 5 to 8 we add 3, 8 to 11 we add 3, so we have a common difference of 3. Our explicit rule for an arithmetic sequence is a sub n equals the first term plus n minus 1 times our common difference. So we're just going to substitute in for our information. Our first term is 2, so 2 plus n minus 1 times our common difference, which was 3. And now we'll simplify this. So we'll distribute this 3, 2 plus 3n minus 3. Combine our like terms, and our rule is a sub n equals 3n, and 2 minus 3 makes negative 1. Our next problem, same type of problem. From 9 to go to 11 we add 2, from 11 to 13 we add 2, 13 to 15 we add 2, so our common difference is 2. A of n equals, or a sub 1 plus the quantity a minus 1 times d, and our first term here is 9 plus the quantity n minus 1 times 2. We'll distribute our 2, 9 plus 2n minus 2, combine our like terms, and a sub n is 2n plus 7. Our next problem, function notation, so we're just going to substitute in a 3 into our function. So f of 3 equals negative 5 x squared plus x minus 2, and we're substituting in this 3. So now our order of operations, we need to square the 3, so this is negative 5 times 9 plus 3 minus 2. Negative 5 times 9 makes negative 45 plus 3 minus 2. Negative 45 plus 3 makes negative 42. Minus 2 makes negative 44. Our next problem, same thing. This time we're substituting in a negative 1 for x, so negative 3x squared plus 2x minus 5. And I write this in specifically for this point, is why I write in parentheses, because when I substitute in a negative 1, sometimes I can get confused and say, oh, is that negative 3 minus 1? But if I put it in parentheses, I know now I need to square the negative 1. So we're going to square the negative 1. Negative 1 squared makes positive 1. Plus 2 times negative 1 minus 5. And now we're just multiplying. We can do both of those steps at once. That makes negative 3. This makes negative 2 minus 5. Negative 3 minus 2 minus 5 makes negative 10. So f of negative 1 equals negative 10. And that's the ordered pair negative 1, negative 10. That means when x is negative 1, our y value is negative 10, or when we input a negative 1, we get out a negative 10.